right, I think. Trying to make sure. Yep. All right. I think we're going. All right. We're gonna do a little bit more on mesh mixing. There was at least one comment about if we could do a little bit more with that. So we'll do some of that. We also last time did a little bit of simple dual color. We'll go through that and actually print the things today. It didn't say it was like 8 minutes or something for a print. So we'll go through and make sure that that's working. And I don't know, then maybe look at a few other things depending on how the time works out. But first, since we want to print some of these little deals that we made, remember we made these in Tinkercad. Got to log into Tinkercad. Tinkercad is free, by the way, so you do have to have an account, but it's a free account. So we made these. Let's see, let's tinker this. I assume I did download it because we sliced it and everything. We made these little guys like that. So we just go and export an STL. You can also export SVGs, which are good for any of your 2D, like laser cut, water jet, plasma, stuff like that. We just want an STL though. Yeah, I did download it. All right. So remember over in Cura, for our dual color print, this would be in downloads, this guy. Now we set this up, I think we set it up for 0.4 millimeter layer heights. This printer that we're going to print it on over here, well, you can see the panel of it over here, has a 0.6 millimeter nozzle, and I believe when I made the part over here, let's see, when I made the part, I believe I made it with the intent that the layers would be 0.4 millimeters. It doesn't really matter. Your slicer can slice whatever, but if you're intentional about, okay, this nozzle has this diameter, then if you make things in increments of that diameter or that layer height that you're going to print, so if you make walls in increments of the nozzle diameter or the line width you're going to use, and layers, height, Z direction height, in increments of the layer height you intend to print, then it will just have a better time of doing it. And I believe I set it up for this nozzle, which is 0.6 millimeter diameter, printing at 0.4 millimeter layer heights. So it won't be, it'll have a little loss of resolution just because we're not printing it as thin of a layer as you might on a regular printer, but I kind of want to just get the point across, not necessarily make super nice parts. So what we wanted to do is we wanted to, first of all, make sure we've got all our stuff. There's 0.4. Let's do 2 walls, and top and bottom layers. This thing isn't, it's almost only top and bottom layers, so 2 is probably fine. 2 top layers, if you don't use a lot of infill, can be a little bit lumpy, because the layers are, having to span across the infill, which might have large gaps in it. So let's go ahead and put it on 3 top layers. It probably is going to be pretty much solid now, but well, no, let's do 2 and just see how it works. And then if it is lumpy, we'll increase it to something else. Let's increase our infill. It's a tiny part anyway, so it's not like let's do 25. Printing temperature, this is a little bit higher than normal because I've got the larger diameter nozzle on there, and so I want to have a little bit more heat going into that filament so that there's a better chance the entire filament melts cleanly. I don't have the outer shell of the filament melted with the core kind of not as melted. So I'm printing it a little bit hotter. 50 is a little bit slow. We could probably do 70 or so. This part's so tiny though that it's never going to get up to maximum speed. So it's never going to have time to accelerate up to the top speed anyway. So 50 is probably fine. We do want cooling. We don't want support on it because there's nothing to support, so might as well not even click that. Let's slice and see what we get. Oh, all right. So one thing, we haven't done our dual color. I did last time mention about the print thin walls. It looks like these all resolved well enough. What we want to do now is we want to figure out what layer to add our color change. So I want, and you know, it does have 3 layers of infill. So there's the infill. So see how it, the layer above the one we're looking at here will be a solid layer, and see how it has to bridge across the pretty sparse infill. That can lead to this layer being a little bit droopy. And the second layer on top of that will probably pick up some of that droop. A third layer would probably be pretty flat. We're gonna go with this and see how it works. It's a little concerning. Oh, I guess that's just a function of the way it was sliced. I'm not sure why the little top symbol starts showing up here and then the rest of it shows up here. I guess it's because it's a thin wall and doesn't have any actual infill at these layers. But I want this background, I want that layer to still be my base color, and then so that's layer 7. Now one thing about Cura is that it counts layers starting at layer 1. In your G code, the first layer is layer 0. So you're going to be off by 1 layer. If you look through your G code and you know it labels the layers, it's going to be off by 1 because it's going to start counting at layer 0. Cura starts counting at layer 1, and so you're going to be off by 1 layer if you're just looking at where things happen. But I want my color change to happen on layer 8. Layer 8 will be the first layer of the new color. All right, so post-processing, modifier G code, we'll do a filament change. You could do a change at Z and just, you know, do a pause or whatever. At Cura's layer 8, this retraction here is how much filament is it going to remove from the printer. 300 millimeters is going to be way too much on this printer because because remember we changed over to direct drive, so it really only has to pull up, I don't know, 50 millimeters or something to get the filament out of here. The 300 is assuming it's going to pull the filament out of the entire Bowden tube, which this does have a tube on it, but this tube is just a guide tube. It's not really connecting anything. It's just kind of guiding the filament so it doesn't come in at some weird angle. So I don't need 300 millimeters of retraction. I need more like, well, I could have a ruler here somewhere. Well, I did have a ruler. It's going missing. I'm going to say I need like 60 millimeters. That should be plenty of getting it. There's 30 millimeters initial just to suck it up a little bit. And then I'll do another 60, which is should be plenty. And it's going to move the print head over to 000. So you could move the filament to, move the print head to some particular location. I'm going to leave it at 000. Although it says that's relative, which would mean it doesn't move. You don't really want to leave the nozzle sitting on top of the print because the nozzle's still going to be hot and it can kind of leave an indentation on the print. So I'm not sure. Let's see if we'll move here for filament change, but Z says it's relative, but the others don't. We'll see what happens. We'll use the M600 for retract. So there's 2 different versions here. One for the Marlin firmware. Oh, you can't see the right screen. Let's see. One for the Marlin firmware and one for the RepRap firmware. We're using Marlin firmware, so we'll try this one. All right, so we're gonna do that. Now it shows down here that I've added some kind of G-code script. We'll reslice, and we will save that. Let me just save it to the desktop somewhere. Let's do multicolor test. Now I want to actually go in and see what it did. So I've got Notepad running over here, Notepad++. I like this one. I've mentioned it before. There's a couple of things when you're working directly with G-code files and you want to edit them. I may not want to edit this one, but this is what my normal process is anyway. But if you did want to edit them, there's a couple of things. One thing is that if you open a G-code file, it is a text file, so you can read it just like plain text. But if you save it from something like Microsoft Word or some actually maybe even Google Docs, you know, if you save it from there, there's a chance that that piece of software is going to add a bunch of header information. You know, if you've ever looked at the source file of a document from Word or Google Docs, then there's all this other stuff about it, like who wrote it, what time it was last edited, what software version it was printed, all this header stuff. That stuff becomes part of the file. Your printer tries to read that and it doesn't know what to do with it, and hopefully it just ignores it, but it could be that it doesn't do anything, like it shuts down. I can't process this, it doesn't look like G-code that I know, so it doesn't do anything. Notepad and Notepad++ don't add that. They don't add any header information, so that will save you some headache if you're editing and saving G-code or writing it from scratch even. The other thing I like is that it's kind of made as a code editor. It's got line numbers and, you know, highlighting and stuff like that. So it's a free also. That's another important part. I like to use freeware, open source stuff when I can. There's no sense in paying for a product when there's a really good free one that does exactly what you need. So that's why I'm using Notepad++. So let's open up this thing. Let's see. I think I saved it on the desktop. There it is. So this is the G code. So all of these semicolons, those are comments. You know, like you might have a / or asterisk or something in some other coding language. Semicolons indicate a comment here. So let's go look, Control F, for layer. There's only a few layers here, so we'll just look at them one by one and see if there's layer 0. Remember I said that the G code starts counting at layer 0. Cura, this is layer 1 for Cura. So I actually want to find layer 8 in Cura, which is going to be layer 7 in here. So let's find, there's 7. All right, so there you can see our our piece of code that got inserted, M600. So if let's just check out marlinfirmware.org, and actually I want to, I never remember, let me, let's see, let's just look up M600. That's not M600. It figured it out. So this is what I was looking for, is all the references to the code. So M600, I've got all these parameters I can add. It added E300, so that's a extrude 300, except M600 means that it's going to retract 30, so you don't do like -30 or something. And then it does U, which the U is amount of retraction for the unload. The E is retract before moving, so basically just does a little remove some of the filament so it doesn't string everywhere. And then the U is how much it's going to keep extracting for removing it from the hot end and the extruder and everything. Then it does X and Y, so these are absolute positions. It didn't even bother to put a Z because I put Z0. So this is going to send it to the front left corner where my origin is. And then it did a comment in there that this is generated by the Filament Change plugin. So it'll retract and move over to the corner. It probably will beep. That's probably part of the M600, is to like give me a warning. Sometimes you can also put messages on the screen. I think, I can't remember. It's the M503. There's a message, a screen message. This one doesn't look like it does that. Oh, well, 503 is report settings. There's a send to screen. I don't know if I can find it easy. Let's see. Oh, this is, that's not what I want. I don't remember all the 117 set LCD message. So you could, like, we could go over here in our code and do something like M117, and then I think you just type in the message you want. Yeah. Time to change filament. So we could do that. I would want to do that before the M600 because the M600 probably needs to finish executing. So there's probably going to be it's going to retract. It's going to tell me to change the filament. I put new filament in, and then I click the button on the control panel. It's going to purge some filament. So there's all of that before it goes to the next line, to this line. So if I wanted to add some message, then I would need to add it before that, or it would execute actually after all of the filament change. I don't want to actually add this because it's fine the way it is. So it looks like this is fine, and it's going to do this right before layer 7, which is layer 8 in Cura, and we'll try it out. So let's put that file on our SD card over here and see what happens. So we can close it here. I don't want to save file. No, I didn't change anything. So it put it on the desktop. We'll have to cycle through a bunch of screens here to find it. There it is. All right, and then we will eject. Got it on the side of the screen over there. All right, so we'll eject that. Let's get something back on the screen. Let's go over here to the printer. Oh, so here's another little aside. I've still got that blue filament loaded. There's the blue. I looked around. This is going to be pretty hideous, these colors together, but I found a little snip of, I get these samples, Box Mountain. I'm trying to find, they're called Maker Box, from Box Mountain. And you get these little, like here's the ones in this one. You get 3 or 4 rolls of sample filament, so they're like 16 meters long. So here's a ABS 1.5, PETG light blue, glass field, so it's a fiberglass, I assume. It says glass, so I assume it's like fiberglass field, PLA natural. I haven't tried that one. It seems really rigid, so it actually seems nice. We'll try that at some point to reduce warping. The one thing that would need to happen is any of these field probably mean that it's going to be abrasive. This one actually says consider a wear resistant nozzle. What that means is you probably need a hardened steel nozzle for that, or it's going to eat up your brass nozzle pretty fast. But that one's an interesting one to print. This is my favorite one though. This is a flexible, so it's really flexible TPU, but it's transparent. We'll have to print something in that and see how it. I haven't seen any flexibles that are clear or translucent-ish. So we'll have to print with something with that and see how it works. You can print this TPU stuff. You can print it on your regular ender, but this direct drive is one of the things it does really well is print the flexibles, because there's very little unconstrained path between where you're feeding the filament in and where it's coming out of the nozzle. Whereas on your regular ender, you've got this long tube that really soft filament has to travel through. So that, remember we talked about the filament inside that tube being basically a spring. Well, if you suddenly have a flexible material in there, it's very springy, and so it can be difficult to print flexibles on an Ender 3, but it is possible because they make different flexibilities of flexibles. So there's some that are kind of flexible, but there's others that are almost like a rubber band, and you can't print very easily, or maybe not at all, the really flexible stuff on the Bowden tube printers. You can print the more rigid but still flexible stuff on them, but if you want the really soft materials, you almost have to have a direct drive like this to have a chance of printing them. All of that to say that I've got this little roll of filament. Now, I have said before that you don't typically want this, right? Because this is going to get tangled up. In this case, we're going to print so little that I don't think it matters, right? We could just have a little tiny string of this thing. The whole print, let's see, I'm looking at Cura over here. The whole print says that it's only going to take, oh, it doesn't tell me. Where's the, oh, it tells me grams. It doesn't tell me length on this one. Oh, no, there it is, 0.3 meters. So a third of a meter, so like a foot, a couple of inches, 13, 14 inches of filament total for our little thing, so it won't really get tangled in that amount of time. You can, like, so you get these sample rolls occasionally if you, or you end up with a little fragment of a roll. You can print these little spools, get over here, these little spools where they come apart. In this case, I don't think it's really necessary, but they can come apart. You've got your little roll. You don't have to wind it on there. You can just put it on there, right? That's the nice part about these that come apart. In this case, I don't think I think it would actually create more trouble than it's worth, because, you know, the thing is going to kind of just still going to flop around there. It would have a little less likelihood to tangle, but for the amount we're printing, I think we're just going to set it on the table and send it through the printer. All right, so let's start. Where do I do with my SD card? Here it is. Let's start a little print, and then we'll come back to it when it wants to do our filament change. In fact, here's a little piece that we can probably use right there. Multicolor test. We'll print, let it do its thing. We'll keep it kind of in the background over there. All right, so we're going to see how this works. It's going to look pretty ugly because I've got this bright kind of saturated blue with a shiny goldish green color on top of it. So I think they're going to not be very attractive looking, but maybe they'll prove the point of dual color. I am going to go ahead while I'm looking at it and undo this, because that will stay, that G-code insertion will stay on future prints until I clear it. And it'll give you all kinds of weird things if you don't forget to clear those. So just like if you don't forget to undo the spiral base mode, you'll get some weird stuff. All right, looks like it's going over there, so let's go to Meshmixer. So last time in Meshmixer, we kind of talked about how you can add models together. So we went to Thingiverse, we grabbed Hero Quest, I forgot what that guy's name is, Chaos Warlock or something. Anyway, we grabbed this little guy, we grabbed a sword, some crystals, and a base, and stuck them all together. What if you want to kind of do the opposite of that? So maybe, let's go get that guy again. He should still be on the computer somewhere. Chaos Mage, there he is. What if we want to print this guy, but we want a giant version of him, and it doesn't fit on our printer? So what the solution would be is like, well, I need to chop him into little pieces and print the pieces and then glue them together. So there's a couple of ways you can do that sort of thing. So one is just directly in Cura. Let's get rid of this part and let's open up. There he is. So obviously he fits right now, but let's say that we want to print him, you know, I don't know, like really big. He might even fit on the printer, but you don't want to take that long to print it. You know, now he doesn't fit at all. So what you can do is you can just kind of like, well, that much fits on the printer. And you can, let's see, I'm trying to think that Prusa does this a little bit differently. Prusa actually has Prusa Slicer actually has an option where you can slice the model and it will separate it and flip it over. We might look at that in a second. Prusa Slicer is another free slicer that is a really good slicer. A lot of people start with Cura for one reason or another, but Prusa Slicer is also really good. So I'm trying to think if this one, if I just slice him, yeah, it won't slice it here. Oh, that was the printer talking. So because he's actually too big for the whole thing, let me scale him down a little bit so that he fits on here. So when they fit like this, you can actually drop them below the surface and slice, and it'll only print the part above the bed. So it'll only print that part. Now you have to be programmatic about this, right? You have to know how far you dropped him down. So you can look right here. this negative 84.5206, it'd probably make a lot more sense to go to like negative 90, right? Or maybe negative 80 looks better. Yeah, that's right, it is waist. So negative 80, so you lowered him 80 millimeters, so that there's 80 millimeters below the surface here that you need to go and print like for your other half of it. Let me load up Prusa to show you what it does with this. So I'm using 2.4.2. There's probably a newer version because I haven't updated this recently, but they're all pretty similar. So that's one way. This is also a good way to say you're printing and you get a clog in your printer and it's a long print. You don't want to just start over on the thing. You want to save the part that you printed. Maybe you got through this bottom part. You actually printed 80 millimeters or sticking on the bed, and you don't want to waste that. You want to print the rest of them and glue them together. You go to your part that's actually on the bed, you measure its height, and then you drop your original model that low like we did here and print the rest of him separately and then glue them together. You could try to print on top of, like if it stayed stuck down to the bed, you could try printing on top of it. That does require a little bit of G-code. Like you basically slice the whole thing and remove all of the layers that did get printed and let it start right on that. That's probably not going to work though. For one thing, if these models sit for a while on the bed, and the bed cools down, they're probably going to come loose. And it's not worth trying to save. What I would rather do is remove the part that did print, measure its height, drop your model down below the bed, print the rest of it, and glue it together if you want to try and save the print. Looks like our little print over here is cruising along, so it won't be long before we need to do our filament change. Prusa's loaded up here. So it's got a really tiny bed on here right now because this is set up for a different printer. So let's just try to find, he must be in downloads. There he is. All right. So let's say that I want to do a similar thing. There is this option, cut, right here. And let's zoom in. You can see where it's letting me pick where I want to cut. Right there looks good. And you have these options. Keep the upper, keep the lower. In this case, let's keep both of them, but let's take the lower one. You can rotate it upside down. Sometimes that helps it print better. In this case, I think it'll print best like this. And then perform cut. And it'll just drop your two models right there, and you can print them side by side. So if you run out of Z height, for instance, but you want to print both the parts at the same time, you could do that. So they've got a nice handy little feature that just automatically does that for you. Now the downside is that it just makes a flat cut right here. So when you go to glue them back together, you just have these flat surfaces which will glue well, but there's nothing that tells it like what orientation that it needs to go to. All right, so it looks like let's go over here to our printer. So it printed some, and now it's moved over here, and it doesn't actually say anything on the screen. I guess you just need to know that, oh, it must be time to remove our filament. I didn't actually hear it retract the filament though, which is, it's got the, what's going to be, do I need to do it over here? I didn't like that. So this one has a tension knob over here that I can remove the tension on the filament and pull it out. But the problem is all right, so the filament in here has a little bulb on the end of it, kind of where it is melted. So what I'm going to do is I'm going to push filament through and then retract it, because I'm having trouble pulling that little bulb out. I could also do this and pull it out from right here. So I'm going to push it through a little bit. Yeah, because it's stuck there. So I'm going to push it through to kind of remelt that bulb on the end and then pull it out. See, it had all this yucky stuff on it. Let's cut that off. I'm not going to bother putting my, well, should I? I think it'll be okay. I'm just going to put our little green in here. I want to cut it at a steep angle to give it the best chance of making it through all the system here. It's actually kind of, I need it to let me feed some filament through, but it doesn't want to. I wonder if I can do, let's see what my options are here. I have resume on there, which is not really what I want. I have extrude. Oh, there it goes. All right. So I've got to get it to line up with the, sometimes feeding filament into here is a bit of a pain. Which it's not wanting to feed in. Let's redo the end. See if we can get it to feed in there. Oh, uh-oh. All right, so that was a problem. So I pushed too hard and I dropped the axis down. I might have even lost my resume. I did. Oh, no, I didn't. No, I didn't. But it might have lost its position. So it's not going to home again. And so it's not going to know where it's at. And that's going to be a problem. So I kind of messed up there. We'll try and fix it. But I don't know. I don't have a lot of hope. So since it dropped, remember these printers, they don't know where they're at. They only know where they're at by dead reckoning. So they know where they started with their 000 origin. But if they slip anywhere, they don't know that they slipped. So I am going to, let's see, I'd like to try and home it. I don't know that it's going to let me do that though. And it wouldn't home correctly anyway because it's going to try to trigger in the middle where there's this little thing. So I'm pretty sure we're going to have problems. So why don't we, I mean, that's a danger with this because that command, the M600, didn't actually retract the filament for this setup. So what we need to do is we might need to write our own little script to do that. We could try that because I'm pretty sure this isn't going to work. We'll try the resume and see where it lands, but I'm not very hopeful. You know, maybe we can, somehow it lost all of the steppers were locked, but they're not locked now. So let's try to manually reset this. And it thinks it's supposed to be over at 00, which is going to be like there. Let's see. Oh, nope. Oh. We missed, and you can see what happened there. All right, so that particular setup for the M600 didn't work with this firmware. This is the TH3D firmware, and it did not do the filament change correctly. So let's try writing our own. That would be an interesting thing to try and do. Make sure that this is all back to where it's supposed to be. I think it is. I think that's fine. So let's just write our own. That'd be a good little thing. What time are we at? 8:34. So why don't we do this? Let's do our Meshmixer, and if at the end we will write our own little G-code insertion point. We know where to put it in our G-code file in Notepad, but the M600 didn't do what we wanted. So let's write our own. But let's finish up Meshmixer first, and then we'll write that. All right. So we got to this part where you can slice them in half. That might be useful. But what if the real problem is I want to chop these arms off because I don't want to support them or something. So let's close this. Nope. We can leave Cura open because we might need it to reslice our model. So we're over in Meshmixer. Here's our guy. Now again, Meshmixer, the scale of things is kind of ambiguous on how big this actually is. So the scale will happen when we put it in Cura or whatever slicer. All right, so let's do the simplest thing. So we've got, well, let's do our analysis inspector, make sure that all the repairs are filled there. Let's make it, should I make it solid? Sometimes the models work better when you go through the make solid, where's it at, make solid, but that takes a little bit longer, you know, to do. We did that last time. I'm going to leave it alone for now and hope it's fine. So I've got this thing, plane cut. So we can just do plane cut. It gives me a plane that has the gizmo I can move around, and I can tilt it. So maybe I want to cut one arm off. Well, let's just do the first one. Let's do this. You can keep both sides of the plane. Right now it's going to keep the top and lose the bottom. Or you can slice it into just groups. So let's say that we were going to keep both. And then the fill type is where you cut it apart, what's it going to do to that surface it cut through. So we will do a remeshed fill. That'll be fine. And so now I've got, well, it didn't show. Oh, I never remember how to show my little model pieces. Well, let's do the plane cut where we don't keep both. There we go. So there, you know, and it does the same thing where I get this flat surface here. The other downside to that is that, let's say I do want to cut one of these arms off. There's not, in this case, it's not really a way that I'm going to be able to orient this plane to cut just the arm, at least not at the shoulder where I would like it. You know, it's going to cut some of this helmet stuff off of there, which is, you know, that's not what I want. I don't want that, right? So that's not what I was going for. So I'm just Control Z to undo that. So I could go in here and select just this little part. And then I could go in and, let's see, sometimes I have to go through and remember how I do this part. Select. Like that. All right, so that, let me look through the options here. This smooth boundary is talking about the boundary of my select. All of these are in the selection menu, right? Maybe it's in edit. There's the plane cut in edit. All right. So now when it should, oh, it lost my, it looks like it lost my selection. Well, let's see, maybe it didn't. Because it looks like it's going to cut through that. Oh, no, it only it only cut what I selected. So I need to do it the other way. Let's undo that. So I need to select all of this stuff and edit plane cut, and it'll chop his arm off. That's one way I could do it. And so there I've got his arm, and now it's kind of raggedy on the other side over here, which is not really what I want, and it's hollow on this side. So the idea is I kind of want to create, that's one way I could chop him up, right? So I could chop him up into little pieces. It might be hard in this case to get the pieces to match up, because now I've got to go create this guy with a flat cut on it. So that's not really the best way to do this either. So in here, got to figure out this. Let's see, if I do separate, it will separate these pieces that I have selected, but it's really jagged. You know, the selection is really jagged. Let's I think if I hold shift, I can unselect stuff, and we can make our selection tool a lot smaller. So let's well, not that small. Let's try and clean up our selection. Let's try and identify where would be a good place to chop his arm off at. The boundary it's making is basically the boundary where those triangles are. Remember, the STL files are just a bunch of triangles. I'm holding down shift to unselect, and you can just regular mouse drag around to select. So let's do something like that. All right, something like that. And we can modify this selection with the smooth boundary and see how it took that jagged edge and it made this blue line. So it kind of made this nice line to cut on. It's not perfectly flat. It's a little bit, you know, ragged here and there, but it is a smooth line. So I can, and you can choose that. You can tell it how many rings to do, you know, around there. You can tell it how many iterations to take on figuring out which is the best boundary. Preserve shape, you know, how close does it match the model. Smoothness, how smooth of a line is it. None of these seem to be actually updating very much. Oh, there you can see a definite unsmooth there, versus once we were about 50, it seemed to be about the same no matter what we did. Preserve the mesh boundary so that the triangles themselves get, if they're the shape of them gets preserved. We do want to create new groups. So now you can see I've got this thing selected very cleanly. And let's see, what's going to be the best way here to do this? I think if I do separate, that will do our best. Let's try separate. All right, so now I've got two parts over here, right? I've got this part and this part. And I can kind of hide one or the other, select one or the other. I could go over here. I'm not sure if I deleted, if I can undo that or not. Let's save. Let's save before I have to redo all this stuff. Meshmixer test. All right, so now I at least have it saved at this point. So you could go around chopping all the little pieces into these separate groups. And these groups, we could isolate a group, make it solid because it's probably this boundary right here. Let's just delete this, and yeah, it's hollow, right? So that's not going to be printable because it's really thin wall shell, which is not what we want. So all right, Control Z does bring it back, which I wasn't sure about. So we would want to go in and take this part, edit, make solid, and let's crank up our accuracy and our make the cell size smaller. I don't know where, something like that. This is the part that kind of takes longer. The closer you want your solid version to match the shell version. Okay, looks like he's back. You can kind of see it's a little raggedy. All right, so we'll accept that. Okay, we need this guy to be solid too. So now I've got, in my part tree over here, I've got the part, I've got the solid part, you know, I've got the original, what was left of the original guy. Let's go ahead and make it solid also. Oh, not pattern, make solid. And there are probably some other ways. If I figure out some other ways to do this, I'll tell you that too. But see how he lost a lot of detail. Let's update that. If you can use the plane cuts and not have to make the process we did here, they work a lot faster and simpler, but they don't always work because you can't always get an infinite plane to line up exactly where you want something to cut. So you can't always do that. All right, so we'll accept that. That looks good. Now, well, it's still thinking. Definitely save when you're doing this kind of stuff. You might even want to save a couple of iterations of the file in case you need to go back. You know, you decide you wanted to make this cut differently or something. But now when I get rid of these, let's delete his arm here. Or, well, no, I deleted his body, I guess. But now he's got a solid surface here. So it's a solid chunk of plastic now. All right, so there he is back. All right, so that's fine because now I have multiple models. Let's get rid of these. So I'm just selecting those and deleting. There's the actual models. You can see our cut line now. It does have a little bit of, you know, seam there. So we might have to do some fill-in primering or something, sanding when we build this thing. But it's got a little seam, but now he's two separate pieces. So at this point, I could just, this one's kind of jaggedy, so that would kind of register it together. You know, it's not perfectly flat plane, so it will register together when I want to glue it back together. If you want to be, maybe you're worried about it being too weak of a joint, and you want some reinforcement in between these two. So to do something like that, I don't know if I scroll over here. So on this bottom window down here, for some reason I can't resize the window. There it goes. There it goes. I just don't have a lot of control over where it goes. But you can hide pieces so you can't see them. And I want to go in and let's just add a peg into this thing that matches a hole in the other thing. So over here in Meshmix, I think it is. Yeah. There are just primitive shapes. So you could, if you wanted to, create your object in Meshmixer. It's probably not best to do that, but you could. I'm going to take this square. The circle would also work as maybe an easier way to do this, but the square certainly will orient itself. That said circle, that's a cylinder. So I'm going to put this guy in here. Obviously it came in way too big, so let's kind of scale it down and line it up with his shoulder. And let's zoom in on that so we can start working on it. So still too big. That's starting to look reasonable. Let's make it longer. That's starting to look like something. I can see where that might be useful. So it's kind of hard to see how far into him he goes. That looks actually pretty far. Maybe we'll make it a little smaller. That looks good. So we could make this as a peg that prints with him, or a separate peg that maybe it's a metal, you're representing some piece of metal or whatever, and it's going to be holes in both of them. So depending on which way you're going to do that, you would do these next steps slightly differently. You know, is this going to be part of the model? You combine them together, or is this going to be a separate, like a third piece? He's got his arm, his body, and the peg is a separate piece. Either of them kind of start the same though. So the idea here is that I've got it in place. Maybe I want to move it over. Something like that. That looks probably pretty good. That might even print if I join that right there. It might print without support. You know, if I get that at the right angle. Maybe might have to tilt it up a little bit more so that I can print this without support under there. Something like that. All right, so let's say that I want to just add this to his body here. I want to duplicate it first. So I think that's might just be copy and paste. Is that it? I don't remember. No, Control V is its view, so I need to actually duplicate this part. Gotta remember how to do that. Oh, is this it? Duplicate. All right, so you, in your object browser over here, you select the part, that's it, mesh SO13, and then there's a duplicate. So now I have a copy of that mesh. I want a copy of it because, so there's two of them here, because when I do the Boolean subtraction thing, it's going to consume the thing I subtract, so it completely gets lost. So I need another one there to be the peg. If you want to print the peg separately, like cut holes in the body and the arm, then you need to make two copies of this thing. So you have three total. You'll have one that makes the hole in the arm, one that makes the hole in the body, and then one that you'll print separately to join them together. I think I'm going to leave this as part of his body. So I just need two. I'm not going to make a hole in the body. I'm going to put a peg on his body. All right, so now let's hide his body. Let's hide one of our things. So we've got one left, and let's show the arm. All right, and I guess I should have checked to make sure that this doesn't poke out of the arm somewhere, and it doesn't look like it does. So now what I want to do is I want to do a Boolean subtraction to create a hole in this arm. So I always forget the order to do these, but let's select his arm and then select. So I held down Control and selected this, and there's Boolean difference right there. And let's see what we get. If I get the wrong thing, you select them in the other order. No, I got the right order. So the part you want to keep, select that first. The part you want to subtract, select it second over in your object browser. And then now I've got this little hole. Now one thing I probably, let's Control Z. One thing that would probably be wise is that I want this to go into this arm. So it would probably be wise to take this and scale it up a tiny bit, right? Where's scale? Transform, it's in transform. So there's scale at 1, and just make the scale into 1 point. I don't know, it doesn't have to be a whole lot. Let's 0.5 maybe. Well, actually we don't need this. Well, let's make them all. All right, so it's just a little bit bigger, so when it cuts the hole in here, that hole will have a little bit of wiggle room in it, so that you can put glue or whatever in there. So we made it a tiny bit bigger, 5% bigger, and I don't know the exact percentage to do. So let's select this, select the cutting tool, Boolean difference, and it's going to think for a bit. You do have some options over here. Precise is usually the best. Max quality, I suppose. If you had some really complicated shape you were trying to use as your key, maybe the max quality would be better. And then you've got the typical things about how many iterations it takes to figure out where to make the cut. This looked good, so we're going to accept that. All right, and so I lost my tool over here. That's what I talked about when you do the Boolean subtraction, you lose that tool. But I still have the copy I made, so I still have that. And I still have his body. So now I'm going to hide his arm. Which one is the arm? That one. And I need to stick these two together, right? So select both of those, Boolean union. I guess the... Okay. It's going. All right, so now I've got, now it's showing different colors here, and it actually did a little bit of jankety shaping on that peg there. I probably should have done the make precise or whatever, because it definitely reduced that into not a peg shape, right? So let's undo that. See how it changed? So we probably need to do max quality, which is going to take longer. Search depth, let's move that. Try to move it up. a little bit. Oh, that's just a preview. I don't know if use intersection curves will help or not. Oh, let's just not auto reduce the result. All right, so let's see that. That doesn't look, it's still got some rounding on it, but it doesn't look as bad as it did. I don't know how much preview is accurate though. That would also be one benefit to using the cylinder, is that it's going to look, it's a cylinder is not going to get reduced, not going to get the corners rounded off. So it looks like I might have a little bit of some weird rounding on some of these corners, but that looks better. And now I have two parts that should fit together, and I can hide one part, so select the other one. So I've just got this and export. STL, let's see, body. And then I can do the opposite. Oh, but it's still exporting. I can hide the body, select the arm, export arm. Then I can go over to Cura, and I should be able to get both the body and arm in there, put them on the desktop. I didn't check how big the files were. Looks like they're kind of large. Or maybe it's because, oh, no, they're not. They're just detailed, they're not large. And so now I've got two parts that, you know, maybe I could have done a better job of figuring out how to orient this cut to make this more printable. Although that generally looks like this part will have trouble printing down here, but it generally looks like it could print well. But now I can, you know, scale them up 500% and arrange them. And you could imagine his other arm being over there somewhere. Maybe I can print them all at the same time. Maybe I could print, you know, at this scale, I could actually print the whole thing in one go. But you get the idea of, you can now scale things up bigger, or maybe you can arrange it to where you have parts oriented to where you don't need much of support material. You could, you know, if you made this round, this peg round, actually the edges came out really sharp on it in here. If you made it round, then now it's kind of posable. You'd have to do a little bit better job on making your cut planar right here so they could twist in different orientations. But there's a lot of different things you can do to split models more than just slicing them through a plane somewhere. So hopefully that'll help, you know, figure out some new things you might can do for printing bigger parts or posable parts, or just something that I've got a project at work where the thing is supposed to be like a seat, like a chair. And we do have a big printer that is capable of printing that size, but this printer is not going to work for that particular application. So we need to chop that up into smaller pieces to print on a still kind of big printer, but not one big enough that can print the whole thing at once. And so methods like this, where you can add these registration keys or surfaces so that they don't just have to butt up against one another, but they have some kind of mechanical fastening, also can be useful for not just, you know, figures. They can be useful for all sorts of types of prints. So that's a good thing to be able to do. There's not, that I know of, and if somebody knows of one, definitely put it in the comments. I don't know of any software that just does that. Like, cut it here and it automatically adds the registrations and everything. I think I remember one, I'd have to try and dig it up. I think I remember one that does do that, but it's not free, or maybe it was kind of a academic thing where they were just trying to get it to work. I don't remember. I've never actually used it. So, but I don't know of a piece of software like Cura or something, or Meshmixer, where you can just say, kind of like draw a line and it splits it apart automatically, adds the registration, reorients the part. I don't know of anything that automatically does it. So as far as I know, you kind of have to do a manual process like this one to add some registration. It would probably be good, you know, these sharp corners would probably be better if they were kind of chamfered a little bit. You could go over here, whoops, and I mean, they look like they're chamfered, but you could go in here and do some sculpting on it to, you know, flatten out those edges. That's an extreme amount, but let's reduce our size and strength, and you could go in and maybe, you know, kind of soften up the edges. I don't know that there's a really good way to do a chamfer. There's flatten, but I don't know if there's a good way to do a chamfer in here. You could take it into SolidWorks and add a chamfer relatively easy. Once you get that STL into SolidWorks, that you can edit, which is a thing on its own. Fusion 360 might be a more direct route to do that. Bringing STL, editable STL into Fusion 360 might be a simpler thing. All right, so that's that. We've got a little bit of time, maybe. All right, we don't want to save any of that. Maybe we can fix up our G code. So here's where we were, and we had, I don't remember the line number. All right, there's where it is. So this didn't work for us. It didn't actually retract the filament. So let's take, it did it at the right time. The part was in the right spot. Like it looks like it had printed the last top layer, and it was going to print the green on top of here. I'm pretty sure we won't get to print this one right now because we're going to run out of time, but maybe we can start and get our file edited. I believe in Moodle, let's look at Moodle here. I believe I had put in a little bit of filament change. Yeah, there we go. So here is kind of a filament change routine. So let's look at this and go through it. So this is on class 13. Let's see if this is actually right. I don't remember. I think it is. So let's just paste this guy right here. We'll leave some room. All right, so it's really badly formatted. All right, let's erase the M600. So G91. So what this is going to do is switch our positioning mode to relative so that we can move relative to where the nozzle currently is. So we're going to lift the nozzle up 10 millimeters. So basically we're going to lift it up so it's not touching our part anymore. Go back to absolute positioning mode. I'm going to line these up so they look neater anyway. They don't actually matter, but now we're back to absolute positioning mode. We're going to go to our origin. So 0, 0. This may or may not work with this firmware, I'm not sure, but what this does is it plays a beeping sound, so you get a little audible signal that it's ready to change filament. M0, which is, I think that's another way to send messages to the screen and wait for it to click. So the M117 just sends a message to the LCD. M0 sends a message and waits for you to click the button until it goes to the next line. I'm not sure that that's going to work with this firmware or not. We'll find out. Now it goes back to relative positioning. The relative is so that this E10 means add 10 more millimeters of extruded filament. So it's kind of like a purge. Here's the M0 again. So now that it's done the purge and you're satisfied, then you click the button on the screen for it to restart the print. And Z minus 10, so remember we raised it up 10 here, so this brings it back down. G90, go back to your absolute positioning. Whoops. Oh, I lost my... Here we are. So we don't necessarily need this minus 10 right here. That might be a little bit dangerous. Let's lower it a little bit. Minus 5. So we still have a little bit of clearance because the nozzle's over in the front corner, and now it needs to move back over to where it left off. The next line is going to be, well, these are comments. These 3 are comments. It's going to be to go, well, here's the next one that actually goes somewhere. It goes over to this X and Y coordinate, basically where it left off, and starts printing again. This one, what is it doing here? 231, the last extrude was 231.71986. Oh, that's just actually keeping up where it was. That's kind of reminding itself where it was. It doesn't do anything there. So this E here is the cumulative amount of filament extruded, except for these right here where we turned into the relative mode. It doesn't account for that. Okay, so let's save that. So all we did, we basically pasted this in, which will manually, so now we're not even using that M600 thing, which didn't seem to work for this printer. So we're just gonna save this on our SD card. Let's save it as, so we can put it on the SD card. There. I want it to be .g code though. Oh, not comma G code. .g code. And yes, let's replace it. I think if you don't put the .g code on there, it will save it as a .txt, and then your printer won't recognize it as G code. So the extension .g code is going to tell it that, hey, this is a file I can print. All right, so let's eject this guy. We technically, if the printer was ready to go, we technically have enough time to get this to go, but we'll see. Yeah, we'll keep it in the editor. All right, so let's see what happens. Print. Oh wait, stop. That was printing the last thing it did. Start printing that one. So it didn't, I should have kept it preheated, but I didn't. All right, so it's going to start out green because that's the color we left in. So it'll be a green base with the blue trim on it. That actually might look a little better than what it was going to look like. These colors aren't picked to actually go together. They're just the two I found right away. So hopefully it'll heat up in time that we can see if this filament change works. It will work on a basic Marlin build. This TH3D, I don't know. You know, and we can continually tweak this thing, this G code, to, because it doesn't have a retract, you know, remove the filament. It's wanting you to manually remove the filament and everything. So we'll see how it goes. It's heating the bed right now. This is, I'm gonna put this on our little hook up there at the top so it's not dragging around everywhere. All right, so now it's heating the nozzle. Shouldn't be too much longer before it tries to print something. The original print, oh, remember our flow rate. I didn't calibrate it, but I did drop the flow rate down to 90%. Our calculations from, where'd it go? From this print told us it was supposed to be dropped down like 60 or 40%, a drastic amount. I dropped it down to 90% flow rate, and it did print. The surface finish was much better, but I haven't gone and checked the E-steps yet. All right, we're getting there. So we're at 160 on the nozzle. It needs to get to 210 before it's going to start its routine. It's got to do the bed leveling, which we might have, you know, got some stuff out of whack here when it kind of crashed into the bed. So the bed leveling might be useful. It's at 193. All right, so it's decided it's going to do its print. Let's see what happens. Got a little bit hanging off there. These are really handy to have, the bent kind like this, because you can get up under there and grab filament that's drooping. Some printer kits do come with tweezers, but they're never the bent kind. I like the bent ones. Grab some more off of there. So there's our 3x3 bed automatic. Well, all right, so it's called Abl Automatic Bed Leveling, but this is not actually leveling the bed. This is compensating for an unlevel bed. There are printers that physically go in and like reorient the bed to level it. So that's true bed leveling. This is better, something like bed mesh compensation. So it's mapping the bed really coarsely for this little bed, but it's mapping it, and then it's going to compensate for whatever it detects as being the shape of the bed. With only 3x3, it's pretty much still treating it like a plane, but it can, you know, figure out a little bit of unevenness. So there's our new color. Let's see. No, none of that. I was trying to see where they've got it in percentage. So I was going to speed it up to speed up our printing. So while not even specific to this firmware, but the firmware that comes on any of these printers, you do have a tuning menu on the LCD screen that you can sit here and watch the filament be coming out and say, you know, I could go faster, I need to go slower, I can increase flow, I can increase or decrease temperature. You have a tuning menu that lets you do those sort of things, change the printing speed. Well, it does it by percentages. So you can increase or decrease the flow by a certain percentage, the speed by a certain percentage, or things like that. So if you see your print is struggling or could do better, then don't be afraid to look at your tuning menu on here. Sometimes you have to click this button to bring up the tuning menu. It's not available, like most of them it says tune. On this one it says percentages, so I don't know why it says that, but I mean they're all based on percentages, but I don't know why it doesn't just say tune. But you can, it's not available unless you're actually printing a part, but once you start printing, you'll get on your LCD screen the option to have this tuning menu that you can go in and tweak things as the print is occurring. I was going to increase our speed, but we're almost on the layer change level, and we'll see what happens. So I'm on my basic screen here. This screen, I don't know where it's going to display the message that we told it to do, so it might just ignore that. Hopefully it'll give us the beep sound to tell us to do something. I don't know. It'll hopefully at least move over here and we'll know to do stuff. We'll find out soon because it's about done with that layer. And my plan is just to put the blue in there, which maybe we need to get this kind of angled. All right, so I think it's about to finish the layer, the last green layer, green gold layer. All right, so it did move over. Oh, we got a pause menu, which is good. It didn't give us our message. That's okay. It didn't really matter. So let's push down a little bit without, and then pull out so that it's easier to remove. And now let's see if we can get this in there without. It did lock the stepper. It kept the steppers locked, so I hopefully won't accidentally push through this time. There it goes. All right, so let's get some, I'm just pushing the green color out so that I get blue. So I'm kind of manually doing a purge. All right, that looks good. Let's tighten this up. Okay. I'm going to push resume on here. See what happens. Okay. That was our little retract, I think, that we coded in there, which I don't think I needed because I just manually did it, but that's fine. And that was the second M0 command. I don't get the messages on this particular screen, but there's resume. And now it's back to doing its G code. Hopefully it's going to drop down to the right height. Oh, it didn't. Oh, well, that's kind of stinky. So, all right, stop. Stop printing. All right. So what happened is, and it was right the first time. Remember, I only dropped it down to -5, but this line after it doesn't have the Z coordinate in it. So it went right to back to the correct XY spot, but it stayed at the Z that it was already at. So what we need to do is, what's the best way to do this? I think the best way to do this will be to add in the Z coordinate here. So the last Z it was at is, let's find it. Well, I don't want to miss it somewhere, but I don't see it either. I might just need, all right, let's go to here. Control find Z, but let's find, I want to find the previous one. I don't want to find the next one. And why is it highlighting all the X's when I typed in Z? That's weird. Backward direction. There's that Z -5. There's the Z10. There it is. It was at 3 millimeters. So if we put X, Y, and Z of 3, that will send it to the right height. Or we could do -10 here to bring it back down to where it was. Why I didn't want to do that is because it might drag across the print, you know, when it goes back to the XY coordinate. So I'd rather it not do that. So if we do it this way, we drop it down a little bit. Maybe we'll drop it down really close, like 9. So it's a millimeter above the print, but it's over in the corner. And then the next line it gets is this one. It's going to go from that point where it's 1 millimeter above. Actually, let's do 2 millimeters. 2 millimeters above where it's supposed to be. And then it's going to go from that point over to X, Y, and Z of 3. So it should drop back down to the right spot to start printing. So we don't have time to run that print, but that should fix it. Or just do the -10 and let it drag across the print when it's going back to the printing spot. That's the way I originally had it. I just didn't want it to drag across the print. All right, so we went a little bit over, but I just wanted to show you that you can write G code from scratch, and if you understand what it's doing, and all it's really doing is moving from point to point. Most of all of the G code is just moving from this point to that point and possibly extruding some filament along the way. And then there are these other machine codes, the M codes, that can do specific things like pauses and beeps and stuff like that. Change temperatures, stuff like that. All right, hopefully next time we can pick up here, print this thing, and it actually works well. Maybe I'll find some better colors that will go together better than these two will. And we can get us a little token. And we'll do some other stuff. We're about to do resin printing is probably the big thing for next time. Unless I get some specific questions about stuff. All right, I will see y'all tomorrow.